Welcome to this exploration of one of the most mind-bending concepts in physics, the relativity of simultaneity. Today, we're going to discover why there is no such thing as absolute time in our universe. This idea challenges everything we experience in our daily lives, but it's fundamental to understanding how space and time actually work. For centuries, scientists believed in what we call the classical or Newtonian view of time. According to this view, time flows uniformly for everyone, everywhere in the universe. This means that if two events happen at the same moment for one observer, they would happen simultaneously for all observers, no matter where they are or how fast they're moving. This seems intuitive based on our everyday experience, but as we'll see, the universe doesn't actually work this way. Einstein revolutionized our understanding by recognizing something crucial. The speed of light is constant in all reference frames. No matter how fast you're moving, light always travels at the same speed relative to you. This seemingly simple fact has profound consequences. It means that simultaneity must be relative. Different observers moving at different speeds can actually disagree about whether two events happen at the same time. Both observers are correct in their own reference frames. To understand this, let's examine Einstein's famous train thought experiment. Picture this scenario. A train is moving at very high speed past a platform. Lightning strikes both ends of the train simultaneously. We have two observers. Observer A stands at the exact center of the train, and observer B stands stationary on the platform. Both observers witness the lightning strikes, but as we'll see, they experience them very differently. Let's first consider what observer B sees from the platform. Since observer B is stationary and positioned equidistant from both lightning strikes, the light from both strikes travels equal distances to reach them. The light arrives at observer B at the same time. Observer B concludes, quite reasonably, that the lightning strikes were simultaneous. They happened at exactly the same moment. Now here's where things get interesting. Observer A is at the center of the train, but the train is moving forward at high speed. As the light travels from both strikes, the train moves toward the front strike and away from the rear strike. Because of this motion, the light from the front of the train reaches observer A before the light from the rear. Observer A concludes, just as reasonably, that the strikes were not simultaneous. The front strike happened first, followed by the rear strike. So why does this happen? The key is that the speed of light is constant and equals c for all observers, regardless of their motion. Since both observers measure light traveling at the same speed, but they're in relative motion to each other, they must disagree about when events occur. This isn't an illusion or a measurement error. It's the fundamental nature of space and time. Simultaneity truly is relative. This concept is mathematically described by the Lorentz Transformation. The equation shows how time coordinates transform between different reference frames. The formula is t prime equals gamma times the quantity t minus vx over c squared. This means that the time coordinate of an event in one frame depends not only on the time in another frame, but also on the position. Different reference frames literally measure different times for the same event. Let's summarize what we've learned. First, there is no absolute time. Whether events are simultaneous depends entirely on the observer's reference frame. Second, both observers are equally correct in their own frames. Neither is wrong. Third, this is a direct consequence of the constant speed of light. And finally, spacetime itself is fundamentally relative, not absolute. This profound insight forever changed our understanding of the universe and remains one of the cornerstones of modern physics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.